friends, this is Srinivasulu branch of CSC, Ashankar Institute of Science and Technology, Guru. This is my third year second semester microcontroller and application desktop presentation video. In this video, we can explain that what is microcontrollers and microcontroller types and uses of microcontrollers. What is a microcontroller? A microcontroller is an integral circuit IC that can be programmed to perform a set of functions to control a collection of electronic devices. A self-contained system in which a processor, support, memory, and input-output are all contained in a single package. Being programmable is what makes the microcontroller unique to microcontroller packaging. From left to right, pick 12F508, pick 16F84A, pick 16C7, 16C72, Motorola 68HC05B16, pick 16F877, Motorola 68000. Types of microcontrollers. Bits. There have four types of bits: 4-bit, 8-bit, 16-bit, and 32-bit. Memory and devices. Embedded memory and external memory. Instruction set వచ్చేసి RISC. Memory architecture. Princeton hardware. Family. There are 7 types of families are 8051, Motorola, PIC, Tesla, National, or others. They have 8051 have Intel, Atmel, Telias, Philips, Siemens. First, according to bits, 4-bit microcontrollers. AL arithmetic logic unit performs arithmetic and logical operations and enable 4-bit at an instruction. Internal bus width of 4-bit. Small size minimum pin count and low cost controllers. Low power consumption and used for low end applications like LED, LCD display drivers, portable battery chargers. Example: Renesas M34501-256 and ATAM862 series from Atmel. In 8-bit microcontrollers, we have used ALU, arithmetic logic unit performs arithmetic and logical operations at a byte 8-bit. They have used in 8 bits of instruction. Internal bus width is 8-bit. Example: Intel 8051 family and Motorola MC68HC11 family. In 16-bit microcontroller, arithmetic logic unit performs arithmetic and logical operations on a word 16 bits at an instruction. External bus width of 16-bit microcontroller of 16-bit. Enhanced performance, computing capability and greater precision as compared to the 8-bit microcontrollers. Examples: Intel 8096 family. Intel bus width of 16-bit microcontroller is of 16-bit. Enhanced precision as compared to the 8-bit microcontrollers. Example: Intel 8096 family, Motorola MC8HC12 and MC68332 families. Intel bus width of 32-bit. Much more enhanced performance computing capability with greater precision as compared to 16-bit microcontrollers. Examples: Intel 80960 family, Motorola M683XX and Intel Atmel 251 family. There have XX are the in-read data bytes. 2. According to the memory or devices. Embedded microcontrollers. An embedded system has a microcontroller unit that has all the function blocks including programs as well as data memory available on the same chip. Example: 8051 have program and data memory. In I/O ports, serial communication, counters and timers, and interrupt control logic of the chip. This is the chip. They have batteries and connections and microcontrollers and etc. This is the LCD light. External memory microcontrollers. An external system has a microcontroller unit that does not have all the function blocks available on a chip. All or part of the memory units are externally interfaced using an interfacing circuit called the glue circuit. Example, 8031 has no program memory on the chip. They have 8031 have no program on the chip. Program memory. This is the external memory of the microcontroller. This is the external memory of the microcontroller. They have chips and pins are connected in this. 3. According to the instruction set, CISC complex instruction set computer architecture microcontrollers has an instruction set that supports many addressing modes for that arithmetic and logical instructions, data transfer and memory access instructions. Many of the instructions are macro like allows the programmer to use one instruction in place of many simpler instructions. Example, Intel 8096 family. This reduced instruction set computer architecture microcontrollers contain an instruction set that supports fewer addressing modes for the arithmetic and logical instructions and for data transfer instructions, allowing simultaneous access of the program and data. Instruction pipelining increases execution. Instruction pipelining is increased as execution speed will be increased. Allow each instruction to operate on any register or use of any addressing mode. Smaller chip and pin count. They have smaller chip and pin will be counted. Very low power consumption. Low power will be consumed. For according to the memory architecture, the architecture of microcontrollers differ in the way data programmers are stored and accessed. Von Neumann Princeton architecture. Single data bus. Single data bus that is used to fetch both instruction and data. Program instructions and data are stored in a common main memory. When such a controller addresses main memory, it first fetches an instruction and then it fetches data to support the instruction. Simply the microcontroller design because only one memory is accessed. The weakness is that two separate fetches can slow up the controller's operation. Example, Motorola 68HC11. This is the diagram of program memory transfer. Program ROM variable stack RAM. Data to transfer, address and control. Memory interface unit MIU. Instruction decode, process and built-in registers. Hardware architecture. Separate to data bus and an instruction bus. Execution occur in parallel. Much faster execution than von Neumann architecture. Design complexity. Example, Intel MCS 51 family and PIC controllers. Control space. Program ROM. Data address control. Instruction decode. PC stack. They have instruction decode to transfer the PC stack. Processor and register interface. Data transfer. Address and control. Register space. General microcontroller architecture. This is the general microcontroller architecture. EPROM ROM to transfer program counter to transfer stack. This is the bus. General purpose register. Watchdog timer, oscillator, instruction register, instruction decoder. They have port A, port B, port C, and arithmetic logic unit 2. This is the diagram of main having the CPU core. ROM transfer the CPU, A and D counter, EEPROM, RAM, serial input, IO, parallel IO, timer, PWM, program word management. Central processing unit CPU. The central processing unit processes the program. It executes the instructions stored in the program memory pointed to by the program counter in synchronization with the clock signal. ALU, an arithmetic logic unit. ALU performs mathematical and logical operations on data. Oscillator, a complex digital device that generates a steady pulse rate required for timing. All of the separate functions are controlled by one central timing system. The timing pulse provided basis for the proper sequence all the separate actions of microcontroller chip. Read-only memory, ROM. ROM is nothing but permanent memory. Permanent memory. ROM holds the program instruction and the constant data. Microcontrollers use one or more of the following memory types for this purpose. ROM, mask programmable ROM. PROM, one-time programmable ROM, which is not field programmable. EPROM, field programmable and used by UV erasable. EPROM, field programmable, electrically erased, byte erasable, and flash, similar to EEPROM technology. Microcontrollers can have 4K, 8K, and 16K and etc. of ROM. Random access memory (RAM) is used to hold intermediate results and other temporary data during the execution of the program. Typically, microcontrollers have a few hundreds of bytes of RAM. Special function registers control various functions of a microcontroller. They have divided into two groups. Register wired into the CPU do not necessary for the part of the addressing memory. Use it to control program flow of arithmetic functions. Examples: status register, program counter, stack pointers, etc. Registers. Register is used to hold the content of data being manipulated. Registers required by peripheral components. The contents of these registers include a set of timer or enable serial communication. Example: a program counter, stack pointer, RAM address register, program address register, PC incrementer. Peripheral components. The analog to digital converter provides an interfacing between the microcontroller, interfacing mediator between the microcontroller and the sensors that produce analog electrical equivalents of the actual physical parameters to the controlled. The digital to analog converter provides an interface between the microcontroller and the accumulators actuators that provide an control function. I/O ports provide an interface between the microcontroller and the peripheral I/O devices such as keyboard, display, etc. Counters, timers are used to keep time and or message the time interval between the events count and the number of events that generate baud rate of the serial port. Watchdog timer, a specialized program found a part of the microcontroller designed to prevent microcontrollers from the halting or locking up because of a user written since program. The instructions are processed step by step. Use a routine that is based on timing. If a program has not been completed or repeated as a loop within a certain amount of time, the watchdog timer issues a reset command. A system reset sets all the registers values to 0. The reset features allows the controller to recover from the crash. It releases the program and sets the controller to start over again. Stack pointer and program counter. Stack pointer keeps track of the last track location used to while the processor is busy manipulating data values, checking ports and checking interrupts. Program counter. It is used to hold the address of the instruction to be executed next. Buses. Bus represent a physical connection used to carry a signal from one point to another inside a microcontroller. The signal carried by a bus may represent address, data, control signal and power. Microcontroller operation module. When a microcontroller is mounted on a circuit board with the other component function as a single unit is referred as a module of a microcontroller board. A microcontroller module typically consists of microcontroller, a power source, an interface for connecting to a programming device, I/O ports and additional memory. A power source powers the controller and any combination components located on the printed circuit board. An interface communicate with the controller. A set of I/O ports. I/O means input output ports. Send and receive signals from the devices the microcontroller is designed to control. I/O ports when programmed as an output pin, each pin can output digital signals. When programmed as the input pin, each pin can receive digital signals. Digit to analog and analog to digit converts change the digital pulse into analog signals. This is the diagram of I/O ports, and oscillator transfer, mainly CPU. This is also visual diagram. Internal operation. The microcontroller consists of thousands of digital circuits that are combined into areas to provide specific functions. The parts of microcontrollers are used to save data and programs, perform math and logical functions, and generate timing signals. The different areas are connected by a bus system. The bus system contains time parallel circuit, tiny parallel circuits that carry the digital pulse patterns from the section to section. The ROM stores the program requires for the microcontroller to function and controls how to chip components operate, and the data and instructions flow through the chip. RAM stores programs and data temporarily. Ports and registers are special memory locations decided to a specific function, such as a hardware locator or a place manipulate data. Advantage features. Advantages features: easy to use and programmable, reusable ability to program using flash, EEPROM or EPROM, flexible and dependable design and simulation, energy efficient, small and cost effective. Ports multifunctionality, high interactions and can fit inside other devices, easy upgrade. Areas of microcontroller application: home monitoring system, automated applications such as robotics, appliances such as microwave, refrigerators, television and VCRs, stereos, automobiles in engine control, diagnostics, climate control, environment control in greenhouse, temperature, humidity, factory, home, instruction, instrumentation, aerospace. Typically microcontroller application: car case controller system, speed measurement, timer control, DA, throttle, set speed, display. Throttle, a device that control the flow of fuel and power to engine. Basic features related to microcontroller and microprocessor. Microprocessor, microcontroller application: general computing, laptops, tablets, appliances, specialized devices. Speed, very fast, relatively slow. External ports: microprocessor have many, microcontroller have few. Cost: microprocessor high cost and microcontroller have low cost. Energy uses: microprocessor used in medium to high, microcontroller used to very low to low. Vendors: microprocessor have Intel, AMD, ARM. In microcontroller has AML, ST, Texas and microcontroller. Criteria of choosing a microcontroller: meeting the computing needs of task and immediately cost effective. Speed, packaging, power consumption, the amount of RAM and ROM on chip, the number of I/O pins and the timer on chip, how easy to upgrade to higher performance or lower performance consumption versions, cost per unit. To availability of the software development tools such as compilers, assemblers and debuggers, wide availability and reliable source of microcontroller. Example: the 8051 family has the largest number of diversifies multiple source suppliers: Intel original, Atmel, Philips, Signistix, AMD, Infineon, Foreign Siemens, Matras, Telecommunication, Maxima. And thank you to all giving this great opportunity for me, and thank you to all.